Hello, and welcome to this session on sanitization, where we will take a look at forensic proofing your data deletion. Really what we're talking about is the sanitization piece. My name is Eric Hibbert, and I am a practicing security and privacy professional who has extensive experience dealing with formal standards, a bunch of different industry associations, and heavily involved in the storage security space. Relevant to this talk, I am the ISO editor for the 27040 storage security standard, both the original published version and currently what's under development. I've been a long time practitioner with the Storage Network Industry Association's Security Technical Work Group. All right, so this session, we're going to basically outline various forms of sanitization and methods used. So you'll hear clear, purge, and destruct used numerous times. So we'll go into what that actually means. And we're going to also look at some storage specific aspects of sanitization, what you need to worry about, what can go wrong, additional measures that may be needed, and then basically a final look at the state of sanitization standards and practices. And with that, let's get into it. So let me start with an overview. So before diving into the sort of the more narrow topic of storage sanitization, it's important to actually set some context here. So data lifecycle management, information lifecycle management as well, typically include a step or an element of this process or life cycle that talks about what to do with data when you're done with it. And you could see on this particular instance, that shows up as destroy, but it might also show up as disposal. But the idea is that there's a conscious decision made as to getting rid of the data. Now, it turns out this is actually fairly important because if you've done it right, you're most likely going to avoid problems with data breaches, and you're going to meet your compliance obligations. And of course, failure to do that means you've probably exposed yourself in ways that you're not really wanting to do. So this sanitization topic is sort of heart and soul of how to deal with some of this destroy. But we'll go a little more depth here on the DLM piece. So destroying data, it turns out, is non-trivial. If you think about it, and this is from a data lifecycle management perspective, if you're going to get rid of something, you got to have all of the instances everywhere it's located, on all the servers, all the laptops, backups, images of data, temporary copies, things of that nature. So that's a tall order for large organizations. From a data storage technology perspective, we design these systems so that they guard against data loss. And so if you're going to make data go away, you have to basically factor that into what you're doing. Otherwise, you may think you've gotten rid of it, but in point of fact, it may still be lurking there. The specific compliance obligations that you have are important to understand. And in particular, this will often drive what kind of record keeping that you need to do. So it's not just enough to basically make the data go away. You may have to prove that that's in fact what you did. And so this record keeping is going to be a critical element of that. It's important to keep in mind that there are very advanced forensic tools that are readily available. And so whatever data destruction mechanism you use, you need to be aware that these forensic tools may be able to bring it back into existence if you haven't taken care of it appropriately. Okay, so when destroying this data, and again, this is from a DLM perspective, the way you go about doing that really looks at the underlying sensitivity of the data that you need to get rid of, and I think equally important is what's the potential harm if the data are actually recovered or inadvertently disclosed. And that's really going to sort of set the tone in terms of what you're doing. If you have the cafeteria menu, it may not be a big deal. However, if it's, employee records or health records or, financial data or trade secrets, this kind of information, you absolutely want to make sure that how you go about destroying the data matches, the importance of the data that you're targeting. There's quite a bit of confusing language out there. So you'll see terms like data deletion, secure data deletion, data shredding, and the list kind of goes on. You note that I highlighted the data sanitization. Basically, with the exception of data sanitization, these are all slang. They don't actually have, for the most part, a formal definition of what needs to happen, what's being done, and so you're never quite clear what is involved here. And so part of what we're trying to do here is make sure that if you're worrying about getting rid of data, that you use the right terminology so you get you get what you're after. Some of these other, as they say in some circles, you pays your money and takes your chances. And that's not something you really want to be doing with sensitive information, sensitive data. All right, so let's take a look at what do we mean by sanitization, since I've sort of raised this red flag and said, you need to use the right language, so to speak, terminology. So the definition, and this is from ISO, there's a comparable IEEE, it's pretty close to this. It's a process or method to render access to target data on storage infeasible for a given level of effort. Sure sounds like lawyer speak, but let me break this down to sort of clarify a little bit. So you notice it doesn't say deleted data or eliminated data, it said access. That's important because you may not actually be able to replace the bits, so to speak, that are recorded in the storage, but you may be able to block access to it. For example, you may be using some sort of encryption technique, or if you destroy it. So, this term is actually carefully chosen to cover a broad range of potential areas. Target data is the next thing to sort of bring up here, and again, it goes without saying that it's the data that you're worried about, but in point of fact, there may be some metadata or control information that is important as well, and so the target data might actually include some of that metadata. It sort of depends on the scenario, but this definition is written so that it allows for that as part of the activity. Last but not least is this infeasible for a given level of effort. Well, that's a fancy way of basically saying over time, things are going to need to be adjusted based on changes in sort of computational capabilities. So what's today computationally infeasible, when quantum computing is regularly available, that may not be the situation. But likewise, as storage technology evolves, we see density on, for example, the difference between like a CD and a Blu-ray, the smaller pieces could result in massive amounts of data. And so you have to basically compensate for that. And the expectation is over time, that's definitely going to happen. So this definition is got some subtle things here, but they actually are fairly important when you look at sanitization. So I mentioned forensics earlier, and just to sort of recap, the forensic tools that are out there dealing with data recovery are quite sophisticated. They are they're very much application aware. So you may have eliminated all the copies on, for example, your laptops, but it may be sitting in email. And forensic tools are very adept at going and looking at all these applications and ferreting out, the data that might reside there. They're very good at finding and retrieving lost or deleted files. So especially on SSDs and hard disk drives, if you just simply deleted it, as long as the bits are still lurking out there on the media, some of these tools have the ability to basically actually recover them. Very good at looking at metadata and the extraction of that metadata. Be able to assemble data from a bunch of different sources. So even if you had deleted a particular file, for example, on multiple computers, you might actually be able to piece it back together by taking the remnants from various systems and essentially reconstructing it. These tools have that ability. And of course, they have the ability to grab what's in memory and essentially do on-screen acquisitions as well. So these tools are used for criminal investigations and whatnot, where there's definitely malfeasant behavior. But what they put in the hands of sort of the average user is some fairly sophisticated capabilities that 20 years ago only certain laboratories, nation states were able to do. That's no longer the case. So this is important because sanitization, when done right, especially if you're talking about drive or media level, it's going to render these forensic tools really useless. That's really, when we talk about sanitization, we are specifically targeting forensic tools as not being able to recover the data. And it's important to keep that in mind. Of course, this isn't necessarily going to make the forensics people happy, but the idea is that if you're making the data go away, then you really do need to make it go away. And this is essentially one of the benchmarks for how successful you are. All right, so let's talk a little bit about the forms of sanitization. Obviously, there's data sanitization, which is the piece where you have data everywhere, and it resides in lots of locations, lots of different forms. And this is really aligned with sort of the DLM destroy. All right, how do you make this go away everywhere? For the rest of this session, we're really not going to focus on that piece. That's a different problem set. What we're going to focus on is storage sanitization. And this breaks down into either logical sanitization or media sanitization. Media is obviously media aligned, so that's like drives and removable media. Logical is more your virtual storage. So if you're familiar, like fiber channel, where you present a LUN to a server that you mount and access, that would be logical storage, and then you're worrying about how do you make data go away in that kind of setting. When we talk about storage sanitization, there are a lot of different aspects that you have to address. I mean, the first one is basically what we were just talking about, is what form of storage are you dealing with? Is it logical versus it media aligned? And that will, to a certain degree, determine what kind of options that you have. So that's the sort of first step in the process. Next, you need to select the sanitization method. And we'll talk about these a little more, but those basically come down to things like clear, purge, and destruct. And those choices are going to be driven by this data sensitivity. So if you have really, really, really sensitive information, you're probably not going to use the weakest method of sanitization, clear. You're probably going to use a much stronger, possibly even destruct, which in this context is we perceive as being the more secure. All right. So once you've selected that method, then you've got to basically execute whatever the sanitization technique is. It tends to be aligned with the underlying technology that you're using. Verifying the results. So did the sanitization actually do what it was supposed to do? And then recording some sort of evidence, proof of sanitization, if you will, once you've completed whatever it is you're doing. So let's move in and talk a little more about storage sanitization. As a starting point, it's important to know what kind of standards exist out there today and on the event horizon. Currently, there's the ISO, so this is the International Standard on Storage Security. It's 27040. It was published in January of 2015. It does include some materials on sanitization. It does get into what you should be doing on specific technology. The problem is that technology is 7 years old, so it includes things like zip drives and Bernoullis and floppies and some of what we have today, but it's also missing things like NVMe drives and whatnot. Another document is the NIST Special Publication 888, which is focused on media sanitization. It was published in December of 2014. Not an accident. Both 27040 and the NIST document are very closely aligned in terms of what to do with specific technologies, which means they're both basically obsolete at this point, for the most part. They're also both guidance documents. So you can't claim conformance with either of these documents because there are no requirements, just guidance. Now that's changing. You'll see that there's a new IEEE standard being developed, 2883. It's the standard for sanitizing storage. This document includes details on specific storage technology, how to go about clearing, purging, and destroying the various forms of media. 27040 is being revised. It's going from a guidance standard to both guidance and requirements. And in the case of sanitization, there's definitely been some adjustments there. All the content that used to talk about how to do technology-specific sanitization has basically been removed, and now what you're seeing is a referral to the new IEEE standard on how to go about doing that. But it does set the stage in terms of what you need to be doing. All right, so I've mentioned these a couple of times. So what do we mean by clear, purge, and destruct? All right, so clear is probably the one that you're most familiar with, in that this is still doing simple overrides, whether it's a one-pass override or it's multi-pass. It's considered a logical technique, and you're going after the user data and all addressable storage locations. That's fine as long as all the places that you want to get rid of are available to you, which is not a guarantee. So you may have a hard disk drive that's got multiple partitions, but maybe only one of those is currently mounted. Well, you're only going to be able to clear what you have access to, and that's part of the challenge with this approach. With purge, again, it's often a logical technique, but there's a physical opportunity here as well, at least in terms of magnetic storage. You may be familiar with degaussing techniques. That is considered in some scenarios a purge operation. The third is destruct, and as the name implies, it's a physical technique that is being used to destroy. Purge and destruct are designed to basically be infeasible for state-of-the-art laboratory techniques in terms of recovery. And so that little layer does impose some requirements on how you go about dealing with these. So let's talk quickly about each one of these. So clear, as I mentioned, is basically overriding. There are some commands depending on the technology using, like secure erase unit, format unit, block erase, and this technique has been around for quite some time, but increasingly it's not really considered all that usable with sensitive data, just because there are potentials for problems here. You may not catch everything and things of that nature. So if the sensitivity is low, it's probably fine. If the sensitivity is high, this is probably not a technique that you want to focus on. Purge. There are specific commands that will go in on some of these devices and do a much more sophisticated elimination of the data. So cryptographic erase, sanitize block erase, these will focus on the entire drive. So it doesn't matter whether you've basically mounted a particular partition or not to do the overwrites. This will go in and actually deal with the entire drive. Another form is what we're calling here media-based cryptographic erase. So unlike the first set here, this is applicable to logical storage as well, where you can actually encrypt all the data that's basically being written to that storage, whether it's cloud, whether it's a mounted file system, things of that nature. And the concept is basically, if you delete the key, it's a little more sophisticated than that, but you render the ciphertext unrecoverable, and that's the Reader's Digest version of cryptographic erase. The third is degaussing. You notice we've got a little sort of caveat on here. It only works with magnetic storage, and increasingly what we're finding is it's not all that effective for a lot of the media that's out there that is magnetic, just because of the densities that are used are causing you have to use stronger and stronger sort of magnetic fields to get rid of it, to a point of you may not actually be able to do it. In fact, some of the degaussing is more likely to damage the drive than fully get rid of the data, and so that's something to be careful about. To sort of continue that thought, you see that from the standards perspective, that the handoff is, if you're going to use degaussing, you need to make sure it's organizationally approved, the field strength, and that is only something that you're going to get from your storage vendor. They're going to be able to tell you how strong that field strength basically needs to be to make the data go away. And you want to pay attention to that, because if you're attempting to degauss and you're using something that's under that, it'll have, well, it won't get rid of the data, but it may actually have an impact on whatever the storage device is or the media. Keep in mind that degaussing, when used as a purge, that when the degaussing is done, the media needs to be, or the device needs to be usable. And if that's not the case, then it's not considered a purge operation. It might be a destruct, but it may not have gotten rid of the data, so it may just be a mechanism to damage, but not sanitize. And so increasingly, degaussing is something you have to use very, very carefully, even on something like tape cartridges. For example, LTO and things of that nature. You may not be able to actually use degaussing to eliminate the data on that form of media. Going back to cryptographic erase, which is part of Purge, the simple answer is destroy the key, destroy the data, right? Well, it's not quite that clean. There's some preconditions, and 27040 lays these out. First of all, if you record sensitive information before you actually start using encryption, all bets are off, because destroying the key does no good, because the data was written in the clear. So it really has to be written as ciphertext for this technique to work. So that's a precondition, and simply activating the encryption and writing data doesn't guarantee anything that was previously written is going to go away as well. The strength of the encryption is important. You should be looking at least 128 bits of security strength. So something like AES should be fine. But if you use some earlier techniques, you could find that the recovery is actually pretty trivial. The keys associated with this, they have to be sufficiently random and a large enough size. Again, 128 bits or greater. For this technique to work. So it's great that you've encrypted, but if it's, if the key is written on the drive, or it's easily, discerned or calculated, you might as well not bother doing the encryption. And definitely the cryptographic erase is not going to work. Of course, last but not least, if you're going to use this technique, you have to ensure that the keys are actually gone, permanently gone. And that may be a problem because you may be using key management servers, have this stuff backed up. You may have escrowed the keys because, encryption can actually be a technology where you can lose data if you don't manage the keys. Well, that management of those keys can then be a problem when you're trying to actually use cryptographic erase. So the strength of cryptographic erase really does sort of play down to the encryption algorithms and the randomness of the keys that are being used. So as long as you handle those appropriately, then you get some measure of protection. But there are organizations that are worried about long-lived data and the expectation that cryptography over time diminishes in value. And so certain kinds of data may not be appropriate, especially if it's this long-lived and it's very, very sensitive, like national security kinds of interests. So that's a scenario to keep in mind. There are some real advantages to using cryptographic erase because it's very fast. Kill the key, kill the data. Whereas something like clear or purge, you may actually have to go and touch all that data. And as these drive sizes increase, that can take days or weeks in some cases. We also see cryptographic erase is sometimes used in conjunction with other sanitization methods, and that can give some added assurances that the data is basically gone. And I guess this final point it's important to make is there's a belief in some sectors, so to speak, that after doing a cryptographic erase, one must do a clear, and that is absolutely not required. But that said, it is one way to attempt to do verification because it's hard to verify something as random if it's random. And ciphertext by its very nature is random, so it's very hard to verify that the cryptographic erase worked if you're trying to do a verification process. So this is a way of doing that. So you do the cryptographic erase, then you do a clear, basically write a bunch of zeros over the data, and then you check to see if you've got data. It seems to make people happy. But it's important to understand that's not a requirement for cryptographic erase. It blows away the data if it's basically been done right. Data destruction, well, or sanitization of the destruct method. This is basically we're disintegrating, incinerating, melting, pulverizing, or shredding. In other words, you're physically destroying the drive or the media. I will point out that we're seeing in the case of pulverize and shred, which result in pieces when the process is done, are increasingly a problem. And part of the reason for that is the density of the storage has gotten to the point where even small pieces could result in data recovery. Obviously, it's not going to be your average user, but depending on the sensitivity of the data, think of a Blu-ray disc versus CD. The difference is in amount of data that you can store on those two different technologies. So a chunk of a Blu-ray disc is likely to give you more information than what you'd find in a CD, and that's really what this is talking about. So you're going to see, I think, over time, pulverize and shred. Their applicability is going to diminish over time. They're already kind of at a point where you're having to worry about the size of the particles, and this is one of those areas where it could change on an annual basis or something of that nature. And organizations want, sort of clear, if we do this form of destruct, then we know that we're in good shape. Those two, have some caveats. All right, so when selecting sanitization methods, since we've talked about clear, purge, and destruct, this little sort of flow chart is, kind of a crude representation of what you worry about. So depending on your choice, if you decide clear is adequate, then what happens is you will come in, look at your options in terms of doing a clear. And if there is one, then you execute it. And then you check to see if it was successful. If it wasn't, then you have to decide, is there another alternative for clear? And if not, then you probably want to move to something like purge. And then you sort of repeat that process. So, there may be multiple options under clear. There might not be. Alternatively, you may say clear is okay. However, there may not be a clear or a purge mechanism, and your only option is to basically do a destruct. This flow sort of shows you how you can sort of work through that. But as you can see, you could, on a drive-by-drive basis, for example, end up starting at clear, then advancing to purge, and then eventually having to destroy it. And this is why some organizations just immediately jump to destruct. They don't necessarily have to, but they don't have the workforce to basically deal with this, especially if they have large quantities of drives or media that they have to worry about. But in general, it's good to understand where in this continuum what's your minimum acceptable method, and but you may find out that you have to use a more advanced method depending on your options. So verification is an important element of this process. When you're dealing with clear and purge, those will typically result in verification through the interface, to see what you can do. You're basically trying to verify that whatever commands or the overwrite mechanism you're using actually did what it was supposed to do. In the case of destruct, it's really a physical inspection of the outcomes. So did you get pieces? Did you get ash? Things of that nature. For clear and purge, the verification, it's recommended that it's a full verification. So all of the drive or all of the logical storage to verify that if it's like overwrites, that you got the right pattern. However, that may not be practical, and if the risk is not too high, then you can get away with doing representative sampling. And the 2883, the IEEE 2883 document actually talks a little bit about what we mean by representative sampling and how one could basically conduct that. In terms of record keeping, it's really important to maintain records of your sanitization, especially when you're doing drive level sanitization. You want to basically document what storage media was sanitized, so things like serial numbers and things of that nature, when and how they were sanitized, maybe who did it, and then what was the final disposition of the storage media? What did you do with it? Did you sell it on eBay? Did you hand it off to somebody? Did you transfer it? You want a record of where did you see it last, and this really comes down to play. If something does show up, from a third party, and there's any questions raised, you have the ability to basically pull up your records and say, yeah, when it left us, it was good. Proof of sanitization can take a couple of forms. Audit log trails, if you're using that technique, so you're getting results from whatever tools you're running, whatever mechanisms you use to do the sanitization, but it means you need to preserve those audit logs for some period of time. Again, back to whatever your compliance obligations are. Alternatively, you can produce a certificate of sanitization, which can be a sheet of paper with certain information on it. It can be a digital form. We're finding increasingly that organizations are using certificates of sanitization, especially if they use third parties to do some of this work. 27040 identifies the kind of information that you probably need to record. So if you're interested in that, the current standard covers that. The new version also covers that. So there's some factors for affecting your ability to sanitize. So first off, if you don't know what the media actually is, so you've got something, you think it's a form of storage, but you're not really sure, maybe it's some form of a tape cartridge, but you don't really know what it is. That's pretty much going to guarantee that you're not going to be using a clear or purge operation, and you're probably going to have to rely on a destruct, and that may be an issue as well. For example, if you have tape technology and you try to pulverize it, you're going to end up with a gooey mess. So, this can be an impediment to sort of general sanitization. But assuming you know kind of what you've got, and you can then make choices, you're right. If you don't, then odds are you're probably going to move right to Destruct. You may know what it is, but you may not have the expertise to sanitize it. Or for that matter, you may not have the ability to do verification on the sanitization, or you might not even have the tools, the software to do it. Again, this is a situation where if that sort of occurs, you may be able to bring in a third party to help you with that. But if that's not the case, then most likely you're going to end up with a Destruct operation. And of course, the software that you need for this is going to be an issue to worry about. So as I mentioned, there are these emerging standards. 27040 is going to be important. It requires sanitization of storage prior to disposal, especially if it's sensitive. It requires verification, it requires proof of, or recommends proof of sanitization. 2883, really a companion, goes into specific guidance and requirements for the technology that you're dealing with and how to do that media sanitization. It helps identify acceptable sanitization techniques for each kind of technology, and that's important. Some final thoughts here. Sanitization of storage, before disposal or repurposing, within your organization, is really considered reasonable security, or as I like to say, does your security pass the giggle test? If you're not doing sanitization of sensitive information, it's not. You're asking for trouble. That trouble comes from so legal requirements or statute or regulatory requirements that are out there, exist today, have existed for quite some time. Mishandled media is a guaranteed problem for some of this and constitutes a data breach the instant you lose control of it. And that's something to keep in mind. Cryptographic Erase is what I consider a power tool, as long as you've set things up so that you can actually use it correctly. Organizations are in many cases just defaulting to Destruct, and I can understand that may be, from an organizational standpoint, the easiest way to deal with this situation, but it's also not an eco-friendly approach. And we are seeing increasingly the need to basically try to be, to minimize the amount of storage that we're putting into landfill, because many of these have, toxic materials, rare earth, minerals, and things of that nature. And the Europeans have already sort of made some movement in this space, and are requiring some sanitization technologies, be available on certain kinds of storage. And of course, last but not least, is make sure you've got the records under control. So thank you for your time today. Hopefully this has been useful information for you. It's also, a bit of a heads up on things that are coming. And so you're in the next probably 12 months, you'll see some of these new standards emerge and start getting referenced and cited in regulations and in other security requirements. So it shouldn't be a surprise. Please take a moment to rate the session. We really do value your feedback. It helps us decide on what kind of sessions to hold at events like this, and the detail level that you would like to see. And as I said, it's been my pleasure to provide some information, hopefully is of value to you, and have a good day.